Yep. Thanks for coming. Maybe some other people will join us because the keynote just starts. But I'll start anyway. So my name is Niels. I'm a developer from the Netherlands. I am a GDE. And I'm going to talk today about Project Fugu. Who here has already done something with Project Fugu or heard about Project Fugu? Who here is a web developer? Yes, great. So we're going to learn a lot of new stuff today. So I am the co-founder and CTO of a company called Salon Hub, and we make software for hair salons. You know, the whole point of sale system for a hair salon, like the cash register, the booking system, the agenda, and it's all based on web technology. It's deployed on desktop right now using Electron. And on tablets using Capacitor. So it is web technology, but it is a native app. But we're trying to roll out our whole product as a PWA instead. And I just love PWAs. These people clearly also do because they look very happy. PWAs are awesome. But I usually don't talk about my job that much. What I usually talk about is just the technology about web Bluetooth and programming Lego cars and JavaScript and fun stuff. But yeah, nobody wants to hear a 30 or 40-minute talk about the exciting world of hair salons and hairstyling. At least not this audience, I think. But today's going to be an exception. We're not going to do any fun stuff today. It's just boring stuff about my job. Sorry. So earlier this year, I got an email from Thomas at Google, and he's part of the Chrome team, and he focuses on Project Fugu. And Project Fugu, that's kind of like a multi-vendor, but it's kind of like led by Chrome effort to make the web more capable. Basically, add new APIs to the web. That kind of makes it better with competing with mobile and better competing with native apps. And in our PWA, we use quite a lot of APIs from Project Fugu, including the APIs responsible for integrating hardware devices like receipt printers, like customer displays and cash drawers. And a couple of years ago, that was not really that simple, but it's getting closer and closer. And thanks to Project Fugu and these kinds of APIs like WebHID and WebBluetooth and WebUSB, WebSerial, it's getting there. And his question was, can we make a demo of our product that show off these APIs? And could we do it in 2 weeks or 4 weeks in time for Google I/O Connect in Miami? 4 weeks. So 2 weeks later, I had a whole demo ready, and it was fully functioning, and it was completely browser-based. And of course, it wasn't 2 weeks' work; it was years in the making. I started working on this probably in 2017 or something, and it was fully functioning. You could scan products, you could print receipts, and everything. And when you scan something, it's shown on the display. And when you pay, you get a physical paper receipt. So with the demo, we went to Miami, and then we went to Amsterdam, and then Thomas took our demo to Bangalore, and in September it was shown in Shanghai at IO Connect. All in all, an amazing experience, and basically this gear has flown over the whole world, and it's now in Italy. So who wants to see the demo? And afterwards, I'll show you how I created it. So through the magic of having two computers, I have now here the demo. That's really. I can basically scan any product. There's a database in the demo that contains all the barcodes and the products and the prices. I can basically scan it, and it shows up in the register. And over here, it shows the products as well. And when I scan the second product, third product, it just works. It's basically a cash register. When you pay, of course, the cash drawer opens, or you would have an integration with a payment terminal. That's also possible. And then finally, you get a receipt. Let's try that again. Oh, never mind. Never mind. It works. So that's kind of underwhelming. It's not really a fancy demo with lights or Lego cars or it's kind of boring and simple, but it's a cash register. It works, and it's supposed to be simple. It's supposed to work. But yeah, you see this every day in a store or a shop. Except then it isn't powered by web technology, and now it is. But it's more complicated than you think it is. It took quite a lot of work to get it working. Like I said, it was years in the making, and I've been working on this technology for the last 10 years or so. So let's go over all the things that I did. Let's start with the receipt printers. So a receipt printer is an essential part of a cash register, and nowadays most receipt printers are USB. They still sell serial versions. They still sell parallel port versions, but this one is USB. So we're going to use WebUSB. There's an API in Chrome and Edge that allows you to connect to a USB device. Basically, well, not any USB device, but many USB devices. And you can then talk to it. But first, you need access to the device. And for that, you call the request device API. And you provide it with a couple of filters. And with those filters, you can basically select what kind of device you want to have. In this case, I'm going to use a filter for the vendor. Every vendor of a USB device has a unique code, unique ID. And in this case, I'm using the ID for, well, in the example, it's the Psycho Epson, who makes receipt printers. Then a dialog pops up on the screen. I can show that. Let's go back to the demo. Let's disconnect the printer for a bit and then reconnect. And a dialog pops up with a list of all the devices that adhere to these filters. Then the user has to select that device and connect manually. So that deals with a lot of security issues because WebUSB sounds scary, but a web page can't just talk to any USB device you have on your system. It's only able to talk to the devices that you specifically allow it to. And then you can do things like open the device and claim the interface, transfer out the data and to the endpoint and all that stuff. Endpoints, interfaces, that requires some extra explanation because this isn't web technology. But even for web developers, well, it may take some getting used to. So USB devices have one or more interfaces. That usually depends on functionality. So if you have a printer or scanner combination, for example, it has multiple functions, and for the individual functions, you have an interface. So for the printer part of it, you have an interface, and for the scanner part, you have an interface. So if you want to talk to one of the two, you have to select the right interface. And every interface has one or more endpoints. And an endpoint, that is basically something you talk to or you receive data from. Okay. So in case of a printer, you have two endpoints, one for sending the data you want to print, sending commands, and one for receiving, for example, feedback about how many sheets of paper you still have in your printer or ink levels or stuff like that. For scanner, you might have one to send commands, scan, and then one to receive all the data back. So back to the example, we open the device. That's something we always do. Then we claim it. We claim one of the interfaces. And that means we are the only one talking to it. Nobody else is allowed to claim the interface because we're doing stuff with the printer. And then we can transfer out to that endpoint. Transfer out basically sends an array of data and sends it to the printer. And this is basically the whole specification. Well, it's a little bit more complicated than this, but this is the core functionality. If you know this, you can basically start building things. So this is how we talk to printers, but we still need to learn the language that printers speak. That is the tricky part. So let's start really simple. We want to print this, just 2 lines, one in bold text, and then cut the receipt. And if we were to do this on the web platform, that would be really, really simple. Just npm install React, and then Tailwind, and obviously have a good think about the build system you're going to use. Some divs, because why use any other elements? And apply a whole bunch of CSS classes, and it's simple. That's, of course, I'm joking. Let's just use HTML. It's a really simple language, just a couple of BRs, breaks, and a V tag for bold, and that's it. But that's not how printers do it. It's kind of similar, but not really. The language used by printers long predates HTML. Let's travel back to 1990. This is the very first receipt printer created by Epson. And well, this technology, it was a dot matrix printer, is based on a 1980s dot matrix printer, also created by Epson, called the MX80. And when they created this, they basically took the whole language from that 1980s printer and used it in this one. And it's called Escape POS. And we've been using that ever since. So if you want to print a receipt, you have to, dig back into history and use 1980s technology. The language is basically ASCII, 7-bit ASCII. And with ASCII, you have all the printable characters that you would need, 26 of them, A to Z, and you get numbers as well, and some special characters. But that's not all. You also have lowercase versions of A to Z, so all the characters that you need. Wow. It's the American standards for American Standards Code of Information Interchange, after all. So who needs special characters, stuff like that. We have some control characters for data transmission, including, for example, the line feed, what we now commonly call a new line. So if we were to send this to the printer, it would work. This is valid escape POS. Just send the text to the printer and it will work. But it's not entirely what we wanted. We wanted to have the second part bold. And to do that, we're not going to use tags, but we're going to use escape codes. And that signals to the printer that we want to do something. What follows is a command. And for example, escape E for emphasis. Now 1 to turn it on, and that makes the text bold. And then escape E for emphasis again, and then 0 to turn it off. This basically does what we wanted. Now, there are a whole bunch of other commands for formatting, for inserting things like barcodes and images, and there's too many to go into detail. There's the manual, it's about this thick. I'm not going to tell you everything about it. Well, we wanted to cut the paper, so we have a command for cutting paper, but we're not done yet. We need to initialize the printer, escape add. We forgot to do that, and escape add basically makes the state of the printer, it forgets everything you've done before. So if somebody else turn on bold, turn on emphasis, your text not going to be bold anymore. It's going to be just initial state. But what about these letters? These are not ASCII. But we don't have Unicode yet. Unicode is in the 1993, I think, something like that. And our printer is 1980s technology. So ASCII, which is fine for the US, but not really for the rest of the world. And even simple character like the euro, that's not part of ASCII. Why is it not working? Yes. Even in America, you have the need for special characters. They have IKEA. And I think IKEA is probably the reason why they started taking internationalization seriously in the US. It's just a theory, but so let's go on a tangent a bit. And in fact, this could be a whole talk about it in itself. Internationalization is so complex that we're not going to even scratch the surface. That's okay. This is not proper internationalization. I can't even pronounce the word correctly. It is internationalization before Unicode. In other words, how can we sell computers to the rest of the world without the least amount of effort possible? Welcome to internationalization before Unicode. There's a little test string in there. Don't use that. That is way too simple to test internationalization support. So ASCII is 7 bits. That means 128 different characters, and we still have another 128 left in a byte. So what if we use code pages, which is basically we swap out a different set of 128 characters. And there are different code pages like Western Europe, which contains all the characters in our test string that we want, which is exactly the reason why you should not use it as a test string. But there's also Hebrew or Greek or Ukrainian, which has its own code page, by the way, which is different than the Russian one because they use a number of different characters. Thai, there are so many code pages. So many code pages. But we want code page 858, which contains all the letters we need in this case. And we select that code page by using escape T, and then use a number for that specific code page. And then we have to translate our Unicode characters to the byte values which are defined in that code page. There's a library for that, luckily. Only it doesn't support most of the code pages used by printers. So that was an issue. So I created a code page encoder library just for printers. I would advise to try avoid working on code pages. Don't do it. And of course, not every printer supports every code page. Some support less. Some support more, but they use completely different numbering, which is Epson created this. So why don't we use the standard that Epson uses? Why? It is really annoying. And it's not just cheap Chinese printers that do this, even established brands. Let's take a look at something else quickly. Cache drawers. What about cache drawers? Well, you can see this model here. It is a combined cache drawer receipt printer. Well, not every model has a combined function. Most receipt printers are just standalone, but they do have a decay port, and you can send a pulse to that decay port. That basically means it sends some voltage on one of the pins. It looks like a modem port. Don't plug in a modem or something. Don't plug in the telephone because it will fry the telephone. It will put 24 volts straight into your device. But you connect the cache drawer to that port, and that pulse then sends the voltage to a solenoid that opens the cache drawer. So it's not a different device. Even if it's separate devices, it's one thing. You use the cache drawer by sending commands to the printer. It's not a different device, it's a function of the receipt printer. So when I started this journey, I really wish there was somebody that would have created a JavaScript library for this. Makes my life a lot easier. And there were some libraries, but mostly server-side or badly written or PHP or Python or JavaScript, but for Node. And I want to create PWA, browser version, so that doesn't work. So I created one. And you can now forget everything I told you so far. You can do this. You initialize the library, then you tell it to print some text, make it bold, cut the receipt, and then encode. And finally, you send it to the printer using WebUSB, like I told you. But wait, it can't be that simple. No, of course not. I mentioned all printers support ESC POS. I lied. Introducing star print, which is pretty much the same as the Escape POS. It's from the same decade. It works the same, except it's completely different. So great. Instead of escape at, we now have escape at can, which is another special character, because we can. And escape T turns into escape GST. And instead of escape emphasis on and off, we now have just escape emphasis and escape F for F this. So if you have a star printer, this is a star printer, escape POS encoder is completely useless. You need something else for star print, like star print encoder. And don't use that. I'll get back to that. So there were several points during this whole journey that I just wanted to give up. There are no standards. I haven't even talked about the different methods of image encoding, barcode support, that differ even between models and manufacturers. Printers that have 203 dpi or 180 dpi. How many characters can fit on one line? Is it 44? Yes. Or is it 40? Yes. Or 35? Also yes. Or 32? Yes. It depends. It's a big mess. So this is how my office currently looks. I've got more receipt printers than what is considered healthy, and it's starting to mess with me. Every time I go into a store or shop, I just look for the receipt printer and see if it's a model I have. And if I don't, I'm wondering, should I get that one? So if anybody says to you, you don't need another receipt printer, you already have more than enough receipt printers. Just ignore them. You don't need that kind of negativity in your life. And the result of this madness is Thermal Printer Encoder, which supports all the printers, and it supports all the different resolutions and all the different code page mappings. And it works like this. It's just you initialize, you tell it the language, and then you just use the same API for escape POS encoder. And then you send it to the printer. And to make your life easier, there's a library for that as well, which is pretty small because WebUSB wasn't that difficult. But to make your life easier, you just connect and print, and that's it. And if you have a serial printer, you can use the WebSerial variant. If you have a Bluetooth printer, you can use the Bluetooth variant as well. All use the same API. And in our demo, we can just select which printer we want, and it then uses the right library for that. So finally, some other devices. The customer display. It basically has 2 lines of 20 characters that we can use to show the current item added to the receipt. So what language does that one use? Do we need to learn another 1980s language? What language do customer displays speak? They speak printer. Again, why? And the reason is found in the 1980s because serial ports, and this is a serial device, Usually computers only had one serial port. So if you wanted to add two devices to it, you had to share the port. And that means you connect it using one of those cables. And then when you wanted to print something, it would also show up on a display. And when you wanted to show something on a display, it would also print it on a receipt. So there need to be some cooperation between the two. They need to understand each other. They need to speak the same language. And basically, what you did was when you initialized the printers or the devices, both were working, and then you send a command like escape equals to turn one off, and then you can use the other one. And when you initialize again, you can turn the other off and use that one. So it's a serial device, so WebSerial. We request a port, and it works the same way as when we request a device using WebUSB. You get a dialog box, and you have to select the right device. And then we open the port and specify the right speed, which is almost 10 gigabytes per second. No, 9,600 bits per second. Okay, it's not really fast, but it works. It works. It's 1980s technology. And then we get a writable stream, and then we write our payload to the stream, sending it to the display. So again, the WebSerial API is really simple. And you can use that API for pretty much every serial device. And that's it. Well, we still have to deal with code pages. And we need to deal with escape POS. But wait, that isn't right. Our display is connected using USB. Why is it using WebSerial and not WebUSB? Because of the 1980s. So USB classes. USB defines a number of default classes. For example, you have a default class for audio or for human input devices. And whenever you plug a device in with one of those classes, you don't need to install a driver or something. It just works. So there are lots of different default classes. When you have a custom device, you do need to install a driver. So we have ACM over there. That is basically a modern replacement for legacy serial ports. And to use ACM, you need to use WebSerial. And WebSerial works for ACM devices, for Bluetooth serial devices, and for the legacy actual old 1980s serial ports. And you use WebUSB to talk to the custom devices. So in this case, it's a serial device, so we use WebSerial. But ACM is a replacement, and it's not really backwards compatible. And most of the USB to serial dongles don't use ACM. They use basically they took their 1980s device, their serial device, and added a custom chip from FTDI or ProLogic, and they are custom devices. But WebSerial also works for these custom devices. But in theory, it is a custom device. You could use WebUSB for that. It would be, you have to reverse engineer how those custom chips work, which takes a lot of time. So I wouldn't recommend it. it will be completely useless because you have WebUSB. Why use WebUSB? Well, you have WebSerial. Why use WebUSB for this? It's a waste of time. But in theory, you could. Don't use it. Don't use it. Don't use it. So in conclusion, almost nobody uses actual legacy serial ports anymore, but some USB devices require you to use WebSerial. And there's a library for that as well. And you can just send text to it and it works. And that brings us to our final device, barcode scanners, which is really easy. We don't need to do anything for barcode scanners because barcode scanners are just keyboards. And when you scan a barcode, it literally just types out the numbers of the barcode, so you could use keyboard events. Of course, you need to figure out what belongs to the barcode and what is just text input. You need to figure out where it starts and ends. It could be solved, but maybe not perfect, but it works well enough. Next. But a barcode scanner is a HID device, so we could use WebHID to get the actual barcodes instead of the keystrokes using keyboard events. So again, we use an API, in this case, the navigator.hid.request device. And then the user needs to select again the device you want to use. Now, we actually get back a list of devices because most HID devices are composite devices. They have multiple functions. In case of a barcode scanner, it's a keyboard, but it's also a barcode scanner. So you have to figure out which part is the barcode scanner part. Because the keyboard part, you can't do anything with that. Because that would be a security nightmare. So we figure out what part is the barcode scanner part, and that is usually defined by a usage page, and that is in a very thick specification. And then we need to tell it to turn off the keyboards and use HID reports instead. And reports are basically events you get whenever something happens. And then you listen for those input reports, and then you get data whenever something is scanned. And in case of our barcodes, we just need to figure out which part of the data is the barcode. But that's pretty easy. This is also defined in the standards. But you don't need to look for that in the standards because there's a library for that. And even if you have a serial-based version, there's a library for that as well. And that was our final device. So do you still think this demo was underwhelming? Or the demo made it look easy. And that's great because it's supposed to be easy for the end user. But it was a huge effort to get this working. Now, for us, this is just fantastic because it allows our app, which used to be a native app, well, using web technology, but the whole part that interfaces with devices, what was written in C#. We can just throw that away. We don't need to deal with C# anymore. We can use just these libraries and it will work for all our customers. And for me, that is amazing that anybody can just use a browser, download an app, or not even download an app, just go to a URL and get this working. That for us, that is just amazing. But maybe for you, Project Fugu is also useful. Maybe not in the way it is for us with receipt printers, but if you have something to interface with that isn't, well, virtual on your desktop, but a physical thing to interface with, you can use these APIs. You just need to figure out how to talk to the devices. And in most cases, there are specifications for that. In most cases, there are probably even, there's example code for it, hopefully in JavaScript even. And otherwise, you may need to look at code in other languages and figure out what they did and make it work on your stuff. You can do so much with it. You can fly drones with it. You can drive around Lego cars and toys, and there's so much fun stuff with it. But you can also read out heart rate monitors and EKGs. And there are actually applications, web applications that talk to medical devices and plot out charts. So this is technology. Project Fugu makes things possible that just wasn't possible before. And that's what I love about these APIs. So thank you very much for listening to me and let me rant about 1980s technology. And if you have any questions, just let me know. And I'll be around for the rest of the day if you want to have a chat.